Hello everyone. In this video we are going to see another important integral which is used in engineering mathematics. So this integral will again use the product rule, and it is basically a product rule, but I will tell you one shortcut for this kind of function. So x cube into, say, e to the power 2x dx. Now this integral, as you see, has an algebraic function x cube and e power 2x dx. If I solve this by using the product rule as shared with you in the previous video, the product rule says x cube as such. Now here we are considering this as first function, this as second function, keeping in mind that because this selection is very important, which one is your first and which one is your second. So like here, this u and this v. So your v should be that function whose integration is known to you, or you can integrate that function. And your u should be the function whose derivative is known to you, or whose derivative will make this integral simpler and solvable. So that is how you choose your u and v. So coming to this, we can see that derivative of x cube is 3x square, derivative of 3x square is 6x, derivative of 6x is 6, and derivative of 6 is 0. So ultimately its derivatives are eventually going towards 0. And this function e power 2x, so its derivatives are going on and on. It will never be 0, and integration also will go on and on. Now for this, the first function should be x cube because its derivative is eventually leading towards 0, going towards 0. So let us apply the product rule. X cube, first function, into integration of second. Integration of second is e to the power 2x upon 2 minus integral of derivative of first. So derivative of first is 3x square into integral of second. So this is your v, this is your u, or this is your first and this is your second. So integral of second is e to the power 2x by 2 dx. And we see this integral still is to be solved. So let us do that in the next step. I can write this 3 by 2 outside, and x square into e power 2x. So integration of this will be x square as such, first function as such, integral of e power 2x is e power 2x upon 2 minus derivative of first minus integral of derivative of first. Derivative of x square is 2x into integration of second, which is e to the power 2x upon 2 dx, and we should close the bracket. Let us simplify it a bit. We still have one more integration sign. X cube e power 2x upon 2 minus 3 by 2 square, or let us write 2 square only, 2 square x square e power 2x, and minus minus is a plus. So this 2 and 2 are getting cancelled out. We have 3 by 2 into integration of x into e power 2x dx. Right, this 3 by 2 is getting multiplied inside, and here this 2 is getting cancelled out, and we get this. Now this integral, again, it's a product of two functions. One is algebraic, one is exponential. We should use integration by parts. So x cube e power 2x upon 2 minus 3 by 2 square x square e to the power 2x plus 3 by 2 into. Now let us see. This integral is first function x as such into integration of second e to the power 2x by 2, first function, integration of second, minus integral of derivative of first. Derivative of x is 1, and integral of this e power 2x is e power 2x upon 2 dx Right? One more integral we have to solve, and it is just e power 2x. So that becomes x cube e power 2x upon 2 minus 3 by 2 square x square e power 2x plus 3 by 2 square, right, x into e power 2x. So plus 3 by 2 minus 1 by 2, I can write minus 3 by 2 square. So when you multiply this 3 by 2 with this term, and what is the integration of e power 2x? It is e power 2x upon 2. So here we get, finally we get rid of this integral sign, and that will be it. And do you see that this is x square this thing can be written as x cube e power 2x upon 2. This is 3x square e to the power 2x upon 2 square. 3x, okay, this is 2 square. If I multiply and divide by 2 here, I'll get a 6x and e power 2x upon 2 cube, right? Just to have it, make some pattern over here, multiply and divide by 2, and here we get okay, this is 2 cube and this is 3, so if I multiply and divide by 2, I'll get here a 6 and e to the power 2x upon, there will be 2 and 1 3 and 1 more 4, one more 2 will be, we have multiplied and divided, so 2 to the power 4. So yes, this was your answer, and we have modified it so that you can see some pattern, 2 square 2 cube and 2 power 4. So that will be your answer for this integral. So how many steps have you done? There is first, second, third, fourth, fifth and sixth. There are 6 steps to reach to this answer. Now let us see a shortcut. That shortcut is valid only if one of the functions is an algebraic function. Let us see what it is. So I'm taking the same integral now, x cube into e power 2x dx. So let this be first function, this be the second function. Now this shortcut method says that you take the algebraic function as such, x cube as such, okay, and integrate the second one, e power 2x upon 2. So we took the first function as such, we integrated the second function, and now we are not going to look at this but these two. We should have alternate signs now. So first term is positive, the second has to be negative, third will be positive, and so on. Now we differentiate this term. What is the derivative of x cube? It is 3x square, and we integrate this term, right? This term has to be integrated in totality. So e to the power 2x integral is e to the power 2x upon 2. There is already a 2, so 2 square in here, plus the alternative plus sign. Now you differentiate this term, 3x square. 3x square will be, its derivative will be 6x, and integration of this term is e to the power 2x upon 2. 2 square is already there, so you can write it as 2 cube. Okay, and derivative of 6x, so alternate negative sign, derivative of 6x is 6, and integral of this term is e to the power 2x upon 2. There will be 4 2's here. What will be the derivative of 6? That will be 0, so we stop here, right? So you see that we have got this derivative, this integral in a single step, right? We got this in a single step, and you can see the amount of work done here and here. So actually this is an observation made from here only. You can see your final result can be written like this by multiplying and dividing by 2 in these two terms, and you get this nice short way to write the answer or the integral of this product. So this is it for this video. I hope you get it. Bye bye.